Hello and welcome to everyone both here in the room and joining us online. In this next session in the openBIM Awards 2025, we're going to be hearing from 5 finalists in the next 90 minutes. 2 different categories. First, we will cover the category of design for buildings. And first, I would like to invite to the stage Agron for his presentation.
Good afternoon, everybody. My name is Agron and I represent our ARGE team. We are from Austria. So it is an honor to be here today in Berlin to represent or showcase our project for the buildingSMART Award entry. I hope everybody had a great lunch and great discussions, especially during the break. I'll try in the next 30 minutes to showcase you the magical moments that we experienced in our project. So spoiler alert, if you want to experience also a little bit of a magical moment, get your cell phones ready to scan a QR code in the later slides. So the project in hand is the technical administration building located in Düsseldorf, Germany. It is an office building mainly composed out of office layouts for the employees of the municipality of Düsseldorf. It's going to be housing also a restaurant for 300 employees. It's going to have internal greeneries. On the ground floor, it's going to have also a public accessible area for the citizens of Düsseldorf. It's going to have 2 underground stories, from which the half of them is going to be covered also by a lake. Currently, we are at the stage of the building permit. We delivered the documentation 2 months ago, the full documentation, so we're waiting anxiously for the building to get approved and start construction. As you can see, it is a rather big and complex project. It has 107,000 square meters gross area, 34 stories, and from the technical side, it has 8.5 kilometers of sanitary pipes or 34 kilometers of geothermal drills. So in total, it has everything is in thousands and hundreds. So in order to document this digital information, we used all sorts of software ecosystems depending on the use case that we're going to deploy. So starting from modeling, we deployed like ArchiCAD, Vectorworks, or even Revit, but also other use cases such as visualization, analysis, quality assurance, or the data enrichment. And it is worth to mention that the core of our collaboration and data exchange stood the IFC4 schema with its additional standards, IDS and BCF. And in order to enhance the collaboration and data exchange, we used additional file formats such as CSV, XML, or even HTML. Of course, IFC models were delivered and exchanged throughout the whole stakeholder team. So we had the architecture with different IFC models, structural engineer, we have HVAC, electrical engineer, landscape architecture. We have, not to forget, 4,200 provision for voids from our electrical and mechanical engineer. And last but not least, we have a very small, but rather also important model, which is from the kitchen planner, containing all the kitchen utilities and machines. On the back end, we also utilized additional IFC models coming from different point clouds that were taken on from the site context. So we had the surrounding buildings, subsoils, layers, terrain, existing trees, or even, important one, is the metro line that is going to be running just beside our building's foundation and the underground stories. So in total, we have deployed 45 different IFC models with almost 1 million components that we delivered in 82 main data drops, not to mention the in-between ones, for a team of 117 people. So when we started this project, it was a clear message for us that we need to align the information requirements to reliable structure. That's why we did in the first step the alignment of the information to the IFC4 schema, very meticulously and detailed, each property containing its entity enumeration or object typing. And we also divided or declared the use cases of how the information is going to be delivered and exchanged, and also declared into the milestones. This was back in the beginning of 2023, but fast forward to 2024, when IDS became a reality, then we saw there an opportunity to translate this information, this rich information from the spreadsheet, into a more reliable data source. So we use an AI agent in order to translate the spreadsheet information But this was done thanks to an IDS template that contained all the 6 facets of the IDS to structure the information. How should the IDS look like? So in the end, we got this magical moment that we see thousands of lines of IDS code that we could then deploy into either Blender for a detailed HTML documentation, or in our common checking software to get a model-based report. When we're talking about properties, at this scale of the project, it was obvious that we need to keep our IFC schemas lean and clean, because probably you are aware that sometimes software is capable of exporting unnecessary and unwanted information, which simply bloats the IFC schema in file size. So in order to avoid such information, unnecessary information, we developed a Python script, which is based on IFC OpenShell, that feeds on the IDS. It sets as a boundary or as a basis to allow or to define which information is allowed in the IFC schema. So when ran against an IFC model, we would get an HTML result with a validation of non-compliant properties and the users that can identify and then remove them from the IFC model. So since our motto is sharing is caring, we made the script available in GitHub so everybody can download it and use it, and we're thankful also for feedback. Data enrichment played also a key role because this was also a step of innovation that we wanted to introduce into our project. So one of the many use cases that we deployed was the transfer of information from one planning discipline to the other one. In this case, the electrical engineer had to transfer or to communicate properties of doors to the architectural planner. So we used these magical spheres that contain the information, and simply by deploying it in simple BIM, we could transfer 17,500 properties to all the doors in a matter just of minutes. So no Excel, no PDF, no emails, just simply via IFC. One of the most successful use cases that we had in our project was the cost estimation. So back in 2023, when we started this project, we didn't have IDS, but nonetheless, we deployed XML as an information requirement for certain BIM authoring tools to define the information properly. For example, like in ARGE, in order to generate an IFC model with the correct information requirements and their data types and data values. From there on, all the IFC models were then taken into I2 to declare a quantity takeoff and cost estimation, from which we produced a PDF report containing 2,411 costing position for all disciplines coming from IFC. And since all information was contained in the IFC model, we utilized also BIM Collab Zoom lists in order to offer our client transparency, full transparency of where those costs are allocated in the IFC model. So this was the communication that was done with the investor, and the magical moment happened here when the public audit office approved also our costs. So public, in German called Rechnungsprüfungsamt. So this is the office that checks if somebody's cheating with the numbers. So they also utilized the BIM Collab Zoom lists in addition to the PDF report, and they could actually identify a minor error that was coming, a technical error that was 0.07% of our costs, which we could repaired in a matter of fast time, and we got a positive approval by the public audit office. Room sheet was another use case that we deployed also here. So the building itself contains quite a lot of components that needed to be documented in a full report of a room sheet. So in order to identify where are these objects located, we utilized all the necessary IFC models that contain this geometrical and alphanumerical information. That was, some of them had actually to be enriched in simple BIM, which further on were taken into the software QBDo to merge the information in order to produce CSV files. From there on, we took the CSV files into Word, and by press of a button, we could generate a PDF report full of information containing 4,492 pages in one document with full detailed properties such as fire safety or surface qualities, and also not to forget HVAC and electrical components such as fire safety or audio appliances located in each room. Such a building has to go through, in the design phase, environmental impact, what it will have. So the use case was that we needed to do a life cycle assessment. But we had a slight dilemma in the beginning of the project because our models were geometrically LOG 300 to 350, but on the other side, we had to do a very detailed life cycle assessment of the building. So in order to align these two universes, what we did is we introduced different mapping systems that could align the IFC information that could be transferred then to Madasta in order to perform the requested analysis. So here in two examples, we have the architectural and the structural engineer, where we divided, for example, IFCs or the model into multiple IFCs, or we merged also information in order to bring it into Madasta. Then in Madasta, we would get, of course, all necessary results, such as recyclability of materials, reuse, but also the global warming potential, fossil and biogenic. And it is worth to mention that in the design phase, our building got the DGNB Platinum pre-certification with a score of 85.9%, which is for our team a great result. One cannot omit, of course, the collaboration aspects in such a digital environment with all the stakeholders. So we utilized BIM Collab as our main hub for issue management, model-based and non-model-based. And this was not only for the planning team, but also the appointing party was involved in this source of communication. Data was exchanged with two different CDEs. On the left side, we see our internal CDE, which is called DPU, and it is actually a development of one of our project partners that integrates different tools such as BIM Collab, SharePoint, Miro, or even MS Teams. So this would allow then a seamless communication and collaboration throughout the planning team. And after performing quality assurance of our models and documentation, then the whole package was dropped to the other CDE, to the side of the appointing party for further documentation or collaboration or approval. So yes, this is the point where you can actually scan the code if you want. This was the aspect that we want to introduce innovation to our client. Because of course we had 2D plans derived from models. We had very detailed models also containing all sorts of information. But we wanted to bring this level of geometry to another level where the client, simply by scanning a QR code, would enter the virtual realm of his building, of his future building, and he could live through the building in a different environment. So we applied materials, lighting, so we gave also a little bit of a mood to the environment. So yeah, so what is the magic of openBIM? So what is the conclusion, what we have, what we experience here? I think my time is running out as far as I know. I could talk not for 30 minutes, but I think I need 13 hours to talk about the conclusions. But to put it in simple sentences, without openBIM, and especially the buildingSMART services and standards, this level of collaboration, transparency would simply not be possible. We delivered a public project on time and especially with an approved budget, and not just by any accident, but because we had a common language for our data, our responsibilities were clear, and simply we trusted the tools that we were using. And to mention above all, we were a team that believed in one thing, that we need to do this thing together. That's why I want to thank my project partners here from the ARGE TVG, and also to mention the appointing party, the project management and the BIM management, IPM, PM, Con, and Formitas. But above all, it is important to mention and thank also the municipality of the city of Düsseldorf that engaged in this futuristic collaboration in a digital world. Thank you.
Thank you, Agron. The next presenter is the Hing Construction Company.
Shall we start? All right. Good afternoon, ladies and gentlemen. My name is Ringo Wong from Hysan Development Company Limited. And here we have Jonathan from Foster & Partners Architect and Dennis from Hing Engineering. We are deeply honored to share with you today about the Lee Garden 8, which integrate the commercial complex, cultural art facilities, and urban garden in Hong Kong. Hysan rooted in Hong Kong over 100 years. We have strong commitment to our social culture as well as sustainability, pursuing top-tier green building certifications to ensure our property not only meet but exceed environmental and occupant well-being standards. Lee Garden 8 was developed through a joint effort with our professional team in an openBIM platform, standardize all project data by using natural and neutral format like IFC, with Foster and partners, along with Hing Engineering overseeing the design and constructions. It set a new benchmark for office and retail development at Causeway Bay as Hong Kong CBD. Hysan adopt openBIM methodology and ISO 19650 in its development, beginning with Lee Garden 8 to enhance design, delivery, and sustainability aligned with S.p.A. without software barrier. And we had ARGE to create a digital twin for Lee Garden 8, and we are planning to extend the digital twin platform to all our existing buildings. This integrated process support our goal and transparency, efficiency, collaboration, sustainability, and data standardization, improve quality, and reduce risk across the entire building life cycle. And now I want to invite Jonathan from Foster and Partner to present the architectural design details. Thank you.
Hello, everyone. Hong Kong, for those who've not been there, is a quite spectacular city. Its atmosphere possibly is stemming from its density. Many, many people on a small piece of land gives it the most unique character, and nowhere more so is that evident than in Causeway Bay, where the project is based. It's a mixed-use project which is trying to amplify the character of its location. And as with all our designs, we wanted the buildings to respond to their urban context. We knew from an onset that this would be a very challenging project because of the site restrictions, and we knew right from the beginning that an integrated team approach was absolutely essential. Not only the world of BIM, of Revit, and so on, but as a human interaction, because ultimately this project is about delivering something for people. There are many stages in an architectural design. The massing that you see here on the right was achieved through all sorts of dialogue with the client to achieve efficient floor plates, studying various computer models to make sure that net to gross was the most perfect it could possibly be. But the reason why this slide is on the wall here is really to talk about the skin of the building. The skin has to do many things, and in a climate such as Hong Kong's, it has to respond to incredibly varied weather conditions. As we're sitting and standing here, there's a typhoon, a super typhoon number 1 about to hit Hong Kong. So wind loads are phenomenally important to design for, but so too is the power of the sun. So with our own in-house plugin modules for Revit, we developed ways of analyzing where the sun shading would most benefit the building so that we weren't putting it where it made no contribution whatsoever. This is a developer-led project, so money is incredibly important and value for money is at the core of the design. Now, these are plug-in scripts that our in-house team have created, and they're all part of this open exchange of BIM information. You'll notice the images in the middle of the screen where the glazing of the facade is featured. There's a high-level clear story glazing. This is a technique to allow daylight to penetrate, but also to provide potential for natural ventilation and also shading of the facade. Typical floor plate, center core, wide open, generous floor plates. The clear story glazing that you can see on, oh, that's gone wrong. At the top of the image on the right, there's a small piece of glass. It's above the horizontal shading element. That can open, allowing natural ventilation in and hot air out, which is all part of a CFD analysis that we undertook in consultation with ARPs, the engineers, to make sure that the quality of the floor plate, whether it's at the perimeter, which is usually referred to as Zone A, Zone B is the yellow, and Zone C is the green. These are different atmospheres, if you like, within a floor plate. They balance the amount of daylight that can be achieved, but also we have to make sure that the air conditioning systems are working and finely tuned for each zone. This graphic here is what happens when the windows are open. So the cool air can come in, the warm air can escape, and you can see by the path of the red arrow that goes from center, middle, up to the top, how natural air is brought into the space. All of these things are possible through CFD modeling, which is part of the whole BIM Revit world that we operate in. We usually start our design work in Rhino, which is far easier to do 3D modeling. Once we move into Revit, which is far more computational, we need to do that at the right stage of a job so that we've made certain key decisions and the refining process can continue. I'm the architect standing here, but behind me, although they're not physically here, are a whole team of engineers, incredibly talented individuals, who each of them, as the speaker for the previous presentation made clear, we're all part of an integrated team. Structures, services, that's all the services, electrical, mechanical, acoustics, lighting, and so on. And indeed, the facade engineers, who play a very important part in monitoring the skin of the building. Now, all of this is done in what's called a federated model. So we're all able to share each other's information. And again, with in-house scripts that our team has created, we can do that in real time. So many times decisions have to be made and a new set of drawings issued overnight, that this interactive ability that a team can work in is super critical. Perhaps I should just dwell on this one a little bit more, because the whole issue of climate change is incredibly sensitive. It's incredibly important. And it's not just about getting to the end of a project and adding all the numbers up and saying, well, didn't we do a great job? There are decisions that are made right at the beginning of a process, which can have a fundamental impact on the amount of carbon that a building will consume. There are three materials listed on the left-hand side. They were the three primary elements that made up the facade systems. Right at the concept stage, quantities that each of these materials would consume. But it's also then doing the research with manufacturers, with the construction industry, engaging with their Revit models, engaging with their published data, to understand how do they get the energy that allows them to produce their aluminium or to process their concrete. All of these fine-tuned elements are part of the overall vision. So the end result, which is the thing that we're talking to you about today, is really based upon many, many factors which were all part of the design process. Now, I'm now going to hand over to Dennis, who will tell you about the actual construction of the project.
Thank you, Jonathan. I'll start with this process map. So the openBIM approach actually is the foundation of BIM across the project life cycle. In the following slides, I will use actual cases to show how we implement openBIM in our project. So our project is located in one of Hong Kong's most sensitive urban community, surrounded by schools, offices, hospital, and heavy traffic. Our target is to meet project goals while minimizing impact to the community. So in 26 months, the project actually will be delivered by top-down construction method with large volume of concrete, steel, and prefabrication modules, especially the MEP DFMA designed for manufacturing and assembly. Actually, over 80% of building services were designed to use DFMA method, resulting in 7,400 modules to be manufactured, which is the highest percentage in Hong Kong for the private development. openBIM approach help keep client, designers, and contractors synchronized around one source of truth. I will elaborate more by using MEP DFMA as a case. We coordinated design information model with rule-based issues and crash detection, used the BCF for issue tracking, and further developed the model with construction details and then to fabrication-ready model. That coordination was critical. By resolving more than 10,000 issues and crashes, the open collaboration enabled the standardization of the modules and the manufacturing readiness. The outcomes from adopting MVP DFMA were significant. We saved 3 months on the program and reduced on-site installation manpower by 30% and cut on-site construction waste by roughly 70%. With higher assembly quality and fewer safety exposures, we cannot have achieved these benefits without open coordination. So how do we carry this design and fabrication certainty into operations? To echo our client's vision to use Lee Garden A as their cornerstone for their digital twin roadmap, we consolidated a workflow to build an asset information foundation for the future development. Start by coordinating with facility managers to create client-specific BSDD profile as single source of truth for asset parameters. In parallel, thanks to openBIM community, we can use open source plugin to enrich model informations and step-by-step develop verified as-built models in a lean and structured.
Repeat that every time you did a data drop, or did you just wait until the end?
Actually, it was done only once, I would say, because after delivering the first IFC models, the unnecessary properties were identified, which were then corrected in the BIM authoring tool for future deliveries, not to integrate them. So this was actually always done like a check if the properties are by any chance still there, but it was actually a first-time process to align the IFC schema.
Same question as, oh, different. All right.
Yeah, for you, I have the question. When did you start to add the client requirements from the BSD database? Because you set up the BSD database yourself, or did the client do that? And so when did you do that? In what phase of the project? And who added the information? And did you add the information to all the different aspect models?
Actually, the stage is the tendering stage, because our clients took the early contract involvement approach. So we involved in this project in tendering stage, and they, based on their vision to build digital twin. So as our client mentioned, there are other existing assets in their portfolio. So in this case, why now we use BSDD to build a client-specific data dictionary for all the future integrations of their digital asset. So actually, we help them to build a client-specific dictionary. Of course, based on their because they're established company with 100 years history, so they do have a system of asset management. The thing what we have to do is to talk to the facility managers to get their knowledge, their asset management structure, to put that structure, transform the paper-based pile of sheets into a digitalized format. Yeah. Thank you. Yes.
I'll ask the same question of both groups, but with the Magic project, you were using what I assume is the modern AI, the large language models, when you were doing your splitting your model into 12 different IDS specs. Whereas in the Lee Garden 8, I'm not sure whether you were using the modern AI or whether but you did use more traditional AI doing the rule-based code checking. Can you comment on how confident you were in the results of what you got out of AI, given that AI is not always 100% reliable?
That's true. That was actually our experience, that AI was not reliable. And that's why we integrated an IDS template we sort of told the AI how the IDS should look like, the structure. So that's why the 6 facets were declared, the prohibited, or especially the requested information, deriving them into object typing or property sets. So without it, without the template, true, the AI was resulting more garbage and actually a non-compliant IDS that could not be run into software. So after running it with the template, we could produce then different IDS files, because we told the AI which parts of the spreadsheet, that was actually one file, which part of the spreadsheet was contained into the architectural model, HVAC. The HVAC was also subdivided into multiple models, electrical or even landscape. So all the information then was structured and delivered in an XML code for the IDS checking.
So in terms of ideas for checking, for validation, actually, and the automated rule-based checking, we didn't use AI because in Hong Kong, the regulation policy is quite straightforward. We know the building codes, we know the rules, and we utilize tools like Solabri and usBIM to do the validation and checking for us. They are pretty mature, so far we can just input out the regulation rules. So we are pretty confident about the result of the checking. Yeah, thank you.
You go first.
Yeah, just supplement a little bit. I think sometimes when we're talking about AI, we may thinking about, do we need some creativity? If the rule is very standardized, like we have an IDS, BSDD, is all fully standardized, simply speaking, automation should be more than enough. But if we want to create something further, exploring some area we don't know, then we should use AI. That's what our intention. Yeah.
I think it's also important to bear in mind that in the design process, there are individual models, but we're an integrated design team. So we have our own, just as a collection of humans, ways of having conversations and regular design meetings. So AI is in its infancy. If we're going to be standing here, if we were to be standing here in 10, 15 years' time, the conversation will probably be different. But at the stage that this was done, it wasn't so necessary. And just the way in which we worked with the client team in the early design stages, we always knew that with a repetitive floor plate and with an aspiration for DFMA or offsite manufacturing, that the design would be, it's not that it's made so simple that anyone can build it, because then maybe it loses some innovative qualities, and we always wish to innovate. But an intelligent design team does this coordination anyway. AI is interesting, and it was the point that our friend here was making about ironmongery schedules, putting little components in, assigning those kind of tasks. Yes, you could get it to do that, but I think we shouldn't lose fact that a good design should be able to be engineered without involving too many other inputs, because then if it isn't, are we perhaps failing as designers? Are we overcomplicating? It's an interesting question, perhaps not for today.
Thank you very much. We'll need to move on to the next category now, but thank you very much to all our finalists. So the next category is technology, and the first presenter is the Tsinghua International Graduate School.
So hello everyone. It's an honor to be here to present our technical solution today. Let's talk about IDS. We all know it, right? It is the foundation for the openBIM workflow, and it is the entry point. It defines the how and what of our information requirement exchange. When the IDS is applied, the whole openBIM workflow works better. It is so important, but how do we create IDS today? We can write it by coding if you would like to. But I think no one really did this in the day-by-day work, the XML, right? And you can use the Excel templates or various editor on web. I think it is a straightforward for every expert sitting in this room to create ideas with these tools. But what about for the project owner, an operator, or a beginner to the openBIM? Actually, if you want to create a valid ideas, you have to spend a lot of time to learn the ideas schema, IFC definition, and know the related classification system. So it is a real challenge for them to create the ideas. But the owners are the ones with the funding, and the new beginners will be the experts in this room, maybe in the future. So we want to create a tool. The tool can lower the barrier of ideas creation. And you can create ideas quickly and fast, and you don't need to be the schema expert. But before we create this tool, we have to solve a fundamental technical challenge: the semantic alignment. For example, for the wall, it has different language version, and it has continuous natural language descriptions in the real project. But all of these natural language descriptions should point back to the one same single entity, IFC wall. So the core challenge of this semantic alignment is how does the automated tool can map all of these natural language description point back to the one same single entity. Can anyone give some suggestions? And we found the best fit technology to solve this challenge: the large language model. We all know it, right? It can understand the natural language. And on this basis, reasoning, summarization, transformation, and execution. So we built a well-designed agent, the arcpath. It's capable of understanding the intent behind the human language and map it to the precise structured requirement of standard schema accurately. Let's take a look. You can type your request in natural language, and just one click, you will get the first draft of the IDS. And you can make any edits before you export it. It's ready to export. You will get the valid and clean IDS file. So this is arcpath, the tool we built to lower the barrier of IDS creation. We built the whole entire process you just saw from the simple request to the final specification just happen in minutes. That is possible because we built the arcpath around some principles. The first, the arcpath is built to be global, supporting multiple languages. You can type your request in Chinese, English, and others. And the arcpath will convert them into the same standardized IDS, truly for the international collaboration. And it has the full document input support. We know that the project requirement lives in the project files, not just in the chat message. So our arcpath can process this document directly, ensuring the seamless fit into your project workflow. And we know that the IFC is a powerful foundation, but it cannot cover every specific requirement. So we may need some extra help. That's why we make a lot of efforts to integrate the BSDD into this process, tailored for the specific requirement. With the BSDD, the arcpath can access more specific definition from the national standard to regional requirement. What this means for you is that you can create the ideas that is tailored to your project context. And finally, you are always in control. Our human in-loop editor is built in for the expert review. So you can validate and refine the agent output before you export it. So how does our agent works? It is a simple four-step journey. First, input. You can type your request in chat message or just upload an existing PDF. And second, content processing. When the arcpath gets the information, it will automatically reading your document and structure the requirement it finds. And third, specification alignment. The arcpath will align your language request with the standards, and it all pulls from the IFC and BSDD to ensure the specification accurate and it is tailored to your local needs. And the final step is valid and output. It will present the final clean and auditable draft to you, and you can make any edits. And once you are happy, you can export it. So, what is the engine powering this simple user journey? It's a three-stage pipeline. Let's break it down. The step one is the file parser. It is the intelligent eyes of our agent. We all know that the project requirements can be logged into the complex PDFs. So our dedicated model first performs the layout analysis and the OCR, the optical character recognize, to extract the content accurately. And we will split this content into chunks, which is preparing for the agent's brand. So the step two, all of these logic chunks will enter the semantic analysis engine, the brain of our agents. It's a two-step process. Firstly, the LLM will recognize the core intent and the technical term from the human language. And secondly, our another dedicated model will organize all that understandings into a predictable and a structured specification. So finally, all of this specification will go to the knowledge base. It is the expert translator of our agents. It first retrieves all the possible schema from the IFC and the BSDD. And our dedicated model will provide an intelligent recommendation to find the best fit properties and entities. And at the end, it will perform the semantic matching to normalize everything and construct a valid IDS data. So it is not just a black box AI. It is a sophisticated pipeline. That's how we ensure the reliability and precision. And our arcpath is not just a tool. It's our contribution to the openBIM workflow. When the IDS creation become easier, the whole openBIM workflow will benefit. This is to help us to increase the adoption of openBIM for everyone. And our arcpath is not just an attempt. We have used the arcpath in the real-world project in Shenzhen International Communication Center, which is a large public project. We have used the arcpath to generate an amount of IDS file. The project team took all of their information requirement document, the EIR, and uploaded it to the arcpath, and later it helped us to generate the IDS file. And all of these files were used to make against a check to the model. So let's break down the performance data. The only key metric that we need to focus is the total time is required of an expert to create a valid and complete IDS. So what is the actual measurable impact of the arcpath in the Shenzhen International Communication Center project, the SICC? To appreciate these results, we first need to know the scale of our challenge. We won't testing this on a small sample. We have used the arcpath to process the project requirement, which included 40 complex IDS files covering 1,000 individual requirements. So how long would this take? The project experts estimated that to do this manually, it will take over 24 hours of a focused expert time. But if we use the arcpath to run through all of these project requirements documents and let it help us to generate the first version of IDS, 32 minutes. It's a raw productivity gain over 97%. But of course, it is only the machine time. The human expert validate and review is essential for the workflow. So for the final results, from the start to the final specification with human expert review, it will take over 6 hours. We still deliver a real-time serving over 73%. It is not a minor improvement. It is a fundamental boost in productivity. So let's bring it all together. First, it is easy. You can state your requirement just in natural language, and you don't need to be a schema expert. Second, it is fast. The process of producing an IDS, which is used to take hours of manual work, now just can be done in minutes. And finally, it is reliable. By connecting the IFC and the BSDD with multiple language service, we can create the IDS with confidence for any project anywhere in this world. And welcome to contact us. We've got a join list, and please feel free to try it. We make the IDS creation easier with arcpath, and let us make the openBIM better together. So thank you for your attention. We are opening for any questions. Thank you.
Thank you. The next presenter is Qonic.
Well, good afternoon, everyone. I'm Dieter Frooijen from Qonic, and I'll walk you through our new AI-enhanced classification tool. Well, every story has a start, and ours started when we took a look at a large data set of different BIM models. These were BIM models, IFC files, coming from different authoring tools, from different disciplines, from different stages in a design, and from all over the world. And they had one thing in common. Their basic classification, IFC entity classes, they were messy and inconsistent. And that's quite strange. You look at the model today and you see a pile, it's an IFC slab. You see a chiller and it's a building element proxy. So even after decades of our IFC schema, there is still something wrong. And that made us think, is it the user? No, we can't blame the user. There are over 100 IFC classes, and how can we expect that everyone in our industry will be able to get to know over those 100 IFC classes? It's still evolving. You also have to be an expert to export your data to IFC from your authoring tool. So we'll forget that. Training is always good, of course. But we thought maybe it's better to look at technology. What can technology bring to the sector? And what we developed was QI, Qonic Intelligence, and that's now our AI-enhanced auto-classification tool. With a short video, I'll show you how it works. It's quite easy. So you have an element or a number of elements selected. This was a building element proxy. You can activate the QI tool, and then it gives a top 5 IFC classes to you. You can choose which one of them is correct. There's also a top choice, but it's still that the user can, they're assisted with the system, and the end result is that it's classified correctly as evolve. Now, I'll walk you through the complete technology behind this. It's completely developed in-house today, and we mimic what we do as a human. As a human, when we want to classify an object, we look at the object like it's a chair. We can see its geometry, its depth, the angle of the surface. We process enormous amount of data to classify it to see it's a chair, and then we can classify it. And it's exactly that's what we did with our tool. We also had first know what the object was, and there's some difficulties in that. As you can see here, it can be a footing, it can be a box, but also could be, for example, two walls in an L shape. So it's difficult from one point of view to exactly know what this object will be. We invented the spherical scanning. So we put around each object a sphere, and we look from every point on that sphere towards the object. So it's something we can't do it as a human, but of course, technology, software isn't limited by that. So we look from the sphere to the object, and then we create this kind of images. And it's not only the geometry, it's also some extra data that we translate into colors. For example, the angle of the surfaces, the depth scanning, and you get this kind of images. I have some other examples. You can shout if you can recognize it. It's an IFC stair. This is an IFC cable carrier fitting. And the last one, we have 10 million of them. I'll stop at 3. This was one of the harder IFC entity classes. It's IFC covering. So we created a large set of these images, all coming from unique individual objects. And then we added the second layer, not only the geometry, but also looking at the metadata, the data that is linked to the object. Sometimes there is no data linked to it. Sometimes you have some. For this example, it's classified as a slab, but there's maybe some useful data linked to it, like footing, like the material is concrete. So that's also a part that the data we use for our training. And then a third layer was a hierarchy of the element in the complete project. It could be, for example, at what level is a element positioned. If it's on the roof, it probably won't be a footing. If it's a part of an MEP system, okay, then it's more likely that it can be, for example, a chiller. So on these 3 layers, and this as a result, we get a prediction that this is a footing. What are the key characteristics of this technology now? It's live. You can use it today. It's in our product. It's commercially available. It's part of Qonic. Qonic is an open BIM platform for authoring your BIM models and for coordination. And this is already a part of the product. It's trained on 10.5 million objects, and we get up to a accuracy of 96%. It's quite huge. It's also not something that is finished. It's a self-learning system, and it evolves with the evolution of IFC classification. So if there is enlargement of IFC classes, if there's some if the IFC schema is changing over time, you don't have to intervene. It will automatically detect them, and they will add them to the suggestions. And last but not least, it's really energy efficient. It runs on your laptop in a split second. It almost consumes no power. And that's quite a big difference with the more generic large language models, because they're building nuclear power plants to provide them from power, and it's difficult to think about sustainable workflows if you're using that kind of technology. And here it just uses really low power for this prediction. This also means that it's very scalable, and that's also part of the future. So we'll be able to have like a health check. Your AI tool will scan your project and will say, okay, you're in the right direction. For the moment, you're at maybe 90% of right classification. So it will help you in knowing if your BIM model is up to the quality as expected or not. It's also that we can make as a background processing. So Qonic, it's an authoring tool. As soon as you start modeling from scratch, maybe it will detect that it's a wall, or it's a window. I forgot the word. yeah, whatever. It will detect as the geometry evolves what the object can be. They can classify it and they can add the property sets, like the common property sets to the object. And it's also in the future maybe possible to, or it is possible to also use data from cloud scanning and also apply the same technology to classify the elements coming from a point cloud. Of course, all of this, it's not just a gimmick, it's with a clear goal we have. And it's like we see, it's hard to see on the image. It's, for us, this tool is like, we can compare it with a skyscraper. Building digital workflows and a skyscraper, what's the similarity? Well, they need both a good foundation. So you can't build a skyscraper if your foundation isn't solid. And it's here exactly the same. For every digital workflow you're building, well, the foundation are these IFC entity classes, and you have to be able to rely on them. So what it does, it will save enormous amount of time, not only for the first check on your classification of your objects, but also during the entire lifespan of your project, constantly checking to the right classification. And of course, this will lead to true interoperability, seamless workflows. It's a foundation, you need it. Otherwise, every process that's linked on this openBIM data, it will become very hard and you'll be fighting the data all the time. So to conclude, we have to thank the community, everyone here in the room, everyone in the building, everyone working on the IFC data schema, because it's only because of this schema that we have structured data and that we were able to train this tool. On the other hand, we also think that with this tool, we can give something back to the community, that we can, at least after some decades, assist the user in easily classifying objects of your project and working with good data. It's the end of my presentation. Just to say that we also have a presentation later this evening. It's in the room upstairs, Stuttgart, at 5:30 p.m. So if you want to see this technology live, then you're all welcome. And I'll end here. Thank you.
Thank you very much. And the final presenter in this category is ACCA Software.
Okay, so hello everyone. Today I would like to talk you about usBIM sustainability. But first I would like to present you the idea that was at the foundation of this technology.
The flap of a butterfly's wing can set a tornado in motion on the other side of the world. In our industry, the same is true. A single design choice can shape a building's environmental impact for decades. With openBIM, business intelligence, and artificial intelligence, we turn scattered data into actionable insights, measuring emissions in real time, comparing alternatives, simulating scenarios. Every decision becomes an act of responsibility. Data is no longer just information. It's the power to build smarter, fairer, and above all, more sustainably. The future is a flap of wings.
So what is usBIM sustainability? It is a collaborative platform for calculating the environmental and economic sustainability parameters of an openBIM model through standards and interoperable workflows. At the foundation lies a simple idea: to try to simplify as much as possible LCA and LCC analysis to bring it to everyone. And to make use of such technology, 3 data sources are necessary. The first one is a BIM authoring tool capable of exporting a generic IFC model. Then we need a cost estimation software able to do the bill of quantities and the cost estimation from such IFC model. And then we need an APD database an APD database is a collection of the sustainability values from the materials and the products from the producers, which are standardized with ISO normatives and that are available from a reputable source, also checked by third parties independently. So what usBIM sustainability does is that it integrates all of these three different kinds of data thanks to the use of AI and BI, so and artificial intelligence and business intelligence, to make sense out of it to conduct LCA and LCC analysis. Then the IFC model is updated with the results of such analysis and is checked for presence and correctness of data with IDS generated from BSTD concepts. In the end, such enriched IFC model is at the center of everything because it's the container that allows us to have such centered and holistic and circular approach. So this is the process map. It's just a quick overview, and then we will go step by step with all the details. So first of all, as we said, data source creation, we need a BIM modeling tool, a cost estimation software, and the APD database with the sustainability values. Then we move on into the data analytics, where AI will help us to make such heterogeneous data homogeneous, and with the use of BI, business intelligence integration, we will get interactive dashboards and so on, where we can see the results of the different analysis. The IFC model gets updated with the results of such analysis, and then there is the validation phase with IDS created with the help of the BSTD. So I think the best way to show this is to talk about an example use of the solution in a real-world project, which features ACCA software headquarter, and in particular shows how this technology has been used to evaluate two different scenarios in the choices of materials with the related LCA and LCC analysis to make decision about which course to take with the objective of a renovation of a part of the building. So let's start with the dataset creation. Again, we used the Edificios BIM modeling tool from ACCA software, but the point is that any IFC model can be used as a starting point produced by any authoring software. In this case, the IFC model, of course, lacks such sustainability parameters, and the point is that as of today, any BIM modeling tool will make it hard for you to calculate and put in the IFC model such values, but this is exactly what we want to do with this solution usBIM sustainability. The second thing that we need is the bill of quantities and cost estimates. In this case, we use the Primus IFC, again from ACCA software, which does everything directly from the IFC model and produces the results, in particular the descriptions of the works, in an XML format, so another open format. And so here we have for each entity the list of the works associated with it. Now, and this is the important part, why we need such cost estimation. The point is that the description of works of a cost estimation software is very, very detailed. It means that it is the description plus all the rate analysis, so the decomposition of all the material, processes, and resources associated with any of the works. So the granularity of this information is very, very, very high. On the other hand, in a generic IFC model, this is not the case because the granularity of this information is quite low. And what we found is that we cannot put the burden of modeling all of such explicit information to the modelers to be put in the IFC model, because that will just not work in practice. And also, from a single IFC model, we can have many or multiple cost estimations, which refers to different parts of the life cycle of the building. Last but not least, the use of an APD database. We use usBIM APD, which is basically a centralized database where we take from other external sources by referencing them, but also by importing into this centralized database all the APD values as stated by the producers of the materials. So not only the description, but also all the sustainability values that we need to carry out our LCA and LCC analysis. Now comes the integration part, the business intelligence and data analytics, which is the true innovation of this technological solution. Let's see how we play this out. The point is that we have these three different data sources, and we have to make a connection between the IFC model and the works that are available in the description of works. And from the quantity takeoff and the bill of quantities, we have to make connection with the APD values that we have available. To do this, we use what is called a join operation. So we have to find out a join operation for the first two, and then another join operation from the quantity takeoff to the APD values. Now, the first one is quite easy because from the FC model to the bill of quantities, we can use the global ID of the entities to know for each entity which are the works associated with it. The other join is a bit more complicated because what we have is description, the description of works and the description as available from the producer with the related APD values. In this case, AI technology with the semantic recognition comes into play. So by looking at the detailed description, also with the decomposition of all the material and resources, we can suggest the best matches that are compliant also with the technical requirements of what is written in the description of the work. And so what this means is that from each of the APD information, we found the matching description of works. As a result, we obtain this data set, which is now ready to be used for business intelligence integration with all the data associated for the sustainability values that we will use to carry on our analysis. So let's see how this is done in practice.
Environmental and economic sustainability through openBIM standards. Within a single common data environment folder, we gather all these essential files. The project's IFC openBIM model, quantity takeoff files with detailed resources, and the APDs of the materials and products required. The platform automatically processes this information using advanced AI and business intelligence technologies, generating a complete data set for sustainability analysis, structured according to openBIM classification. All data converges into an intelligent dashboard, an interactive environment that enables visualization costs, CO2 emissions, and other environmental indicators. Choosing the most effective representation. Analyze multiple scenarios in real time for dashboards. Navigate the building in 3D and identify elements like insulation, distinguishing recyclable from non-recyclable. Once the design is defined, every element of our FC model is enriched with costs and environmental data, which can be aggregated or disaggregated at any level. Data relationships can be graphically represented in the most functional ways to support decision making. By selecting specific indicators, such as CO2 equivalent, The system automatically calculates the corresponding IFC 4.3 stated properties, like climate change, and enriching the model with standardized environmental cost data.
So for the data validation part, then we use a standard IDS workflow. So the updated FC model is validated according to the exchange information requirements using such standard IDS workflow, which again has been created by taking properties definition as defined from the BSTD to check that all the elements actually have the sustainability parameters that we wanted to require. In particular, for this project, we used the IFC 4.3 standard and the IDS and the BSTD for checking. The model contained more than 1,500 openBIM objects, and in particular, the properties have been filled in with the standard BSI property sets, the environmental impact indicators and the environmental impact values. In the example, we just show how to calculate one of the properties, the climate change, which is the CO2, the carbon emission, but the same concept applies for the other properties as well. In particular, the IDS contains 20 specifications with more than 100 detailed requirements and has been created taking more than 20 properties definitions from the BSTD. As a conclusion, we show the integration of openBIM, BI, and AI to give actionable insights to support the LCA and LCC analysis. The resulting information, by using the FC model at the center, allows for a holistic and circular approach using exclusively openBIM workflows. Such integration with the EPD database allows to explore construction alternatives in a very fast and simple way, so as to carry out LCA and LCC to everyone by lowering the learning curve on how to use it. So we think that usBIM sustainability is perfectly in line with creating lasting value from existing resources for future generation. And one last thing, remember the butterfly wings effect? Well, imagine what happens when scaling all of this to a territorial level.
Enabling broader territorial assessments. Our solution integrates openBIM, business intelligence, and artificial intelligence, transforming project data into concrete, measurable, and transparent decisions that support sustainability. The future is in a flat point.
So on behalf of me, Enrico, and Maria Grazia, the other project leads, thank you very much for your attention.
Thank you, Michelangelo. You can stay there, please, and I'll invite the others back to the front. Perhaps come somewhere in the middle here, and then we'll go to the jurors for any questions.
Thank you very much. So we have 3 juries. So I wanna ask to the ACCA software, Michelangelo. Yeah, very great work, and then it's quite new for our industry, but the main workflow is very simple. You explain that IFC and then bill of quantity and then some material information we upload, and then AI and BI create that sustainable some analysis LCA. But what's the difficulty to create the system, or how it works? I heard that your system is on the cloud base. So behind your system, some kind of some big AI engine outside are connected to, and then cast all data and then learning data. So what's the architecture? Is my question.
So thanks for the question, because this gives me the opportunity to explain more what's behind the scene. Yes, it is a cloud system, but in particular, the AI technology behind it is a semantic recognition. It means that when you have a true description, in this case, of one coming from the APD databases, it's easy to convert them in numbers, and there are AI algorithms that will give you the most matching ones. So on top of the rank, you will see the most similar ones. In this particular case, this technology, the algorithms are pre-trained, which means that there is no need to use the data from the users to make other training about it. And I also want to answer about the challenges, because it is important to understand that when you have a description of work, you will have the matching, most matching APD values or the products, basically, that the system, the AI can help you find. But such products are from producers, from actual producers. So the actual choice needs to be taken from the user, because we cannot say use the material from producer A or from producer C. So user will be helped in finding the products that match the technical requirement as described in both description, the one from the cost and the one from the APD database. The final choice is from the user, which has the responsibility. Okay, I want to try the producer A. And if I want alternative scenarios, like in this case, then I can say, okay, I want to try producer A, producer C, and producer D. So it speeds up this process, but in the end, it's still responsibility from the user to decide what final product to use. The AI is an accelerator for all of these process.
Okay, with the ARCpath, you've tested ARCpath on data from a real building. Is much of the results from that use easily transferable to other buildings, or do you need to spend some time customizing the rules that you've generated for new projects?
The well-designed ARCpath agent, the initial idea of we built this agent is to make a unified IDS generator. So for the specific project, if you don't have the specific requirement or definitions come across the IFC or BSDD, you don't need to make any customization of our ARCpath. Yep. Thank you for your question.
Then I'll ask a question to Qonic. So how do you deal with so in your 3 examples, you showed the IFC stair, or a stair that was like, this is an IFC stair, but how do you deal with these things? Because these are, of course, containers that contain IFC stair flight and slab landing and railings. So do you just see the stair, or do you also go deeper into the element assembly to actually add the information to the elements within the stair?
Well, it does take into account the assembly structure. So that's part of what the hierarchy analysis do. That's IFC stair can be also containing a stair flight, a railing, IFC railing. So you can detect the railing as IFC railing, or you can detect the whole as IFC stair. So it goes into the different levels and uses also the structure to see if it's rather a stair than an IFC stair flight.
Yeah, so the first ARCpath, yes, I think you generate the pure IDS file by using LLM. But how do you think the skipping, the creating IDS, but directly check the IFC model and what's the error is? Why you follow the process and not skipping creating IDS is my question.
Okay, thank you for your question. Just like I mentioned in the slides, the IDS defines the information requirement exchange. So it is the foundation for our model check or that follows openBIM workflows. So we want to make the first step solid to validate the power of the large language model, and our engineering team, that we have the ability to solve the semantic alignment challenge in the openBIM workflow. So as a result, we have validated ALM has the capability to solve this challenge, and our team has the engineering capability to solve this challenge. So when we created the IDS wheel, I think we make the first step solid, and the IFC model check or IFC directly generated can be solved in another method, or just in the future. We will have a test in the future to make the IFC model to generate directly. But I still think the whole openBIM workflow included the 4 components. They are necessary for every project. So IDS cannot be ignored. IFC is the future, and IDS cannot be ignored. So that's my answer. Thank you for your question.
Thank you very much to all our finalists. That concludes these 2 categories. The judges will go away and deliberate now, and we'll be back in 30 minutes for the final session of today, the last 2 categories. Thank you.